Question number 4 wants us to find the point on the line y equals 4x plus 7 that's closest to the origin, justifying our answer. So the first thing I'm going to do is just really roughly sketch out what we have here. Y equals 4x plus 7 is a line through 7 with a slope of 4, so it looks something like this. The origin is here, so the point closest to that origin is going to be a point somewhere around here. We don't know what that point is, so we're just going to call it xy. And we know this is the origin, so we're going to call that 0, 0. Now, what we are attempting to do is closest to the origin. That means we're going to minimize the distance. Well, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we want the closest, so we're going to minimize that. Now, before we attempt to do so, we got to eliminate some of those numbers. Now, the nice part is we know the origin is one of the points. So x1 and y1 are both going to become 0. So this becomes a simpler thing. It is the square root of x squared minus 0, so x squared, plus y squared, and that's all we need. So if that's the case, now we can go ahead and try and optimize that, which is a much simpler prospect. So first off, before we attempt to optimize that, that has too many variables. So we're going to come back up here, and we know that y is equal to 4x plus 7. So we're going to take the square root of x squared and 4x plus 7 squared. And that's going to be the thing we attempt to minimize. Now, the problem with that is it's not simplified. So we're going to go ahead and multiply that out. That's going to give me x squared and 16x squared. And 4 times 7 is 28, so 56x. And 7 times 7 is 49. When we combine these, we're going to get 17x squared plus 56x plus 49. That is the thing we're trying to minimize, and that is the thing we're going to call our function. Now, there's good news for taking the derivative of this. I mentioned this in class, but I'm going to mention it again. When you are optimizing a radical, you only need to optimize the inside. So this is going to be my function without the radical. Because radicals are increasing functions, you can optimize just the inside and get the same result. So optimizing that is going to be a lot easier. My derivative then just becomes 34x plus 56. A much easier derivative than the square root would have required. So now we go ahead and find our critical values. To do our critical values, we set that equal to 0. So 34x equals negative 56. So x equals negative 56 over 34, which reduced is negative 28 over 17. Now, that is half the point. To get the other part of the point, what we're going to do is go ahead and plug that back in. So y is going to equal 4 times negative 28 over 17 plus 7. Well, 4 times negative 28 over 17 plus 7 simplifies down to 7 over 17. So that means the point that is closest to this is negative 28 over 17 and 7 over 17, which resembles where we thought it should be. This is a left and up. This point was left and up back here. So that's a good sign. Now all we need to do is justify this. And to justify this, we're going to take the second derivative. Our second derivative is really easy here. Our second derivative is just 34, which is always greater than 0, meaning it is concave up, which means we have found the minimum. So our answer to this problem is that coordinate.